Hello once again, welcome to this short video. In this short video we're going to be discussing the differences between exo and endothermic reaction processes. So as you can see from the screen, what we have are two different reaction profiles that have been already listed. You have seen these before in our previous videos, and so we're just going to start explaining the differences between the two of them. So the first one which we have, the one on the left, is the one that is representing or depicting the exothermic reaction process, and then the one on the right is depicting your endothermic reaction process. So when you are looking at these, there are some things that are common in both of them. So what you will realize that, for example, the both of them are drawn on an axis of energy content versus the extent of reaction, and they will all have reactants. They will have an activated complex, which is at the top of the profile, and then they'll have products, right? But what we're going to then be able to appreciate as well are the differences that exist between the two of them. But before we get to that, we just need to show that, okay, in both of these, you have what is known as the activation energy. That is the difference between the energy content of the activated complex and the reactants. Now that is the minimum energy that reacting substances need to have before they can take part in effective reaction collisions to form products. So what you realize is that they both have activation energies. And now those activation energies may be different, but both of them do have that. All right. And then the other thing that you will realize is that there is the first stage of that activation energy, which is the bond breaking stage. Right. So here bonds are being broken. Which bonds? The bonds of the reacting substances are going to be broken so that they can be available to form new bonds, right? So this process is bond breaking, and it is an endothermic process. And then we also see this other side after the activated complex. That is your bond formation process, right? In the bond formation process, the process is exothermic, and in here you've got your exothermic process as well of the bond formation. There may be differences in the extent or the size of the reaction that's going to take place, but from there we are going to be able to maybe discuss that when we look at the differences. So the first and obvious difference that we have, or that we can appreciate, is the following: the energy content of the reactants as compared to energy content of the products, right? So energy content of one reactant versus the energy of products, right? What do we observe? In the exothermic process, the reactants have more. In exothermic processes, right, the reactants have higher energy than the product. Therefore, in endothermic process, you would say that the reactants have less energy than product. right? And so the other thing that you are also going to be able to state or recognize is that the EA, the activation energy of reactants, or the activation energy of exothermic reaction in the forward process is less than that of the forward process for the endothermic reaction. Right. The other thing that you are also going to be able to observe, which is quite clear, is that the HR, the enthalpy of reaction, delta H R for exothermic reaction delta HR is less than 0 or is negative, and then delta HR for the endothermic process delta HR is greater than 0, which is going to be a positive answer. Right, another thing, if you were to do the reverse reaction, looking at the reverse reaction, the EA for the reverse reaction the enthalpy or the EA activation energy for the reverse reaction for your exothermic process, that EA is going to be higher than the EA for the endothermic reaction. EA for exothermic is greater than that of the endothermic reaction. This means that it is easier to reverse the endothermic reaction than the exothermic reaction. And what else? You could also say something similar for the forward reaction, that it is easier to carry forward the exothermic reaction than to carry forward the forward reaction for the endothermic process. So yeah, that's it. These are some of the differences that you can include when you're, or that you can consider when you're looking at your endo and your exothermic reaction processes. I hope you liked the video. If you did, please press like, send us your comments and feedback, share and subscribe to our channel. Thank you very much for watching, and we will see you when we meet in the next video.